Okay, so a Chapter 5 review, your Chapter 5 review. Of course, the Chapter 5 and the Chapter 9 test are together. The reviews are separate just for organization's sake. So, in the first question here, you're given that f of x is equal to 2x minus 3, and g of x is equal to 3x squared minus 7x minus 9. And you're asked to find g composed with f as a function of x. So, to be able to do this, we need to know our function composition. Hopefully, you're doing okay with that. I'm going to switch to a pen here. You might be able to see better. So the key is knowing what our g of f of x means. G of f of x says an input x is going to go into f, and then that result is going to go into g to give us our final output. So this is really defined as g evaluated at f of x result. So all we have to do is take f of x and put it inside g. F of x is equal to 2x minus 3. So those are interchangeable. So that 2x minus 3 has to go into g. Well, g says take 3 and multiply by your input squared, so 3 times that input squared, minus 7 times the input, minus 9. And then it just comes down to simplifying. Square that out, so square the first, twice the product, square the last, or you could just do FOIL, whichever you prefer. Distribute the 7 minus 14x plus 21 minus 9. So distribute that 3, 12x squared, so 2, minus a big old 36x plus 27 minus 14x plus, I'll go ahead and subtract those. Was that 12? So 12x squared, 36 minus 14, negative 36 minus 14 is what, 50? So minus 50x. And then 27 plus 12 is 39. So that's your result. So the key is just making sure you're putting one into the other properly. Okay, for number 2 here, excuse me, you're asked to use the compound interest formula, which you were given, and the continual interest formula to answer the following question. So you have amount is equal to principal times 1 plus r over n, where r is your rate and n is your number of times compounded per year, raised to the nt, where t is time in years, and you're told all of that. And amount equals PERT, where again, amount, ending amount, principal means starting balance, R is the rate for continuous growth, compounded all the time, continuously, and again, T is time. And E is Euler's constant, the 2.71828, your big fancy E. So you're asked, given a starting amount of 3720, so P equals $3720. 9 years, so T equals 9. And interest rate of 6.7. So the rate is, be sure to, however you express it there, be sure to use it in its decimal form. And then in part A, you're asked to compound monthly. So that makes n equal 12 for 12 times per year, there being obviously 12 months in a year. Excuse me again. So our amount is going to equal our principal, 3720, times 1 plus our rate, 0.067, over how often it's compounded every year, so 12, raised to the n times t, so 12 times 9. And really, because this is the amount you're looking for, you're really just chugging this out. You're asking your shiny box, please do this multiplication for me, and the exponents and the adding and all that. The big warning I would give you is make sure when you raise this, you use your little caret, you raise that in parentheses. So you're raising it to the entire 108. You're not raising it to the 12 and then multiplying that result by 9. So parenthesis management when you're doing exponents can be really important. But put that in, chug that out, you should get something like 6787.25 as your ending amount. You're then asked in part B to do it daily. Daily is n equals 365. You could use 365 and a quarter if you really, really, really wanted to for the whole leap year thing, but it's probably not necessary in this context. So A equals our 3720, that's still our principal. 1 plus, that 1 is for the 100%, plus that rate divided into 365 pieces is actually what you're getting every day. And how many days? Well, 9 years times 365 days. Again, make sure when you evaluate, that's in parentheses. And you'll end up with an amount slightly larger, 6798.27, slightly larger than you got monthly. The smaller your time interval between compoundings, the larger your return is. You're getting more interest on your other growth. So every day, every next day, you get growth on the interest you made that day. Here, you have to wait a whole month before you start seeing benefit from those extra interests. So it's always best to have as small an interest as possible. The best interest is continuous. On continuous, you do have to switch to the PERT formula, because if you tried to plug into this n equals infinity for infinitely compounded, you'd run into computation trouble. But you found in part of your reading, it talked about the limit as n goes to infinity of 1 plus 1 over n to the n, which handles all those being infinities. That turns into your constant e. So that's where part of this formula is coming from. Why the r comes up and why it ends up being exactly this, I think is in your appendix, and it's not too hard to show. But that's where this nice formula, often called PERT, P-E-R-T, PERT, is derived from, and why that e is so important. But we're just given our values here, so 3720 e to the, we're told the r, again make sure it's in decimal form, times t in years, 9 years. We don't have to deal with that n because that n is infinitely often, it's continuous growth, and that n is what builds that e. But again, you can now just evaluate that, and you should end up with the largest of any of your values, 6798.65, excuse me, which is only slightly larger than your daily. But if you're talking about vast sums of money, it does make a pretty big difference in the long run. So really, these are just kind of, plug it in and chug it out kind of questions. But do be aware that in any of these, you could be asked to solve for a time instead. You could be given an amount and solve for the rate, solve for the n, solve for the t, solve for the principal balance. Any of those manipulations are important, are things you should be able to do. Okay, so that's number 2. Number 3, you're asked to evaluate without using a calculator, just really to practice your logic. And you're asked log base 3 of 81. And really this question is about, do you understand what logs tell us, what they're asking for? Logs ask the base to what power makes the argument. So the base of 3, this is really asking 3 to what power makes 81. 3 to what power equals 81? Well, we ought to either know or be able to figure out 3 to the 4th is 81. We presume it's going to be some nice whole number because we're asked to do it without a calculator. And 81 is 9 times 9, and 9 is 3 and 3, so you have 3, 3, 3, and 3, so 3 to the 4th. So what does that mean log base 3 of 81 is? It means log base 3 of 81 is 4, because 3 to the 4th makes 81. You always want to remember this excuse me. You always want to remember this connection between logarithmic statements and exponential statements. They really do form a pair. Just like multiplication and division form a pair, addition and subtraction form a pair, powers and roots form a pair, exponents and logarithms form the same type of pair. Let's look at 4. 4, you're given a function, p of n, equal to 57 minus 92 times the natural log of 1 minus 3 over n. And he told you this models the price per bike seat, P. Excuse me, I'm sorry about the cough. As a function of the number of seats purchased. Find the price per seat if you purchase 25 bikes. So you're just being asked to find P at 25. So again, this comes down to plugging in and evaluating these values. So again, you could simplify this piece by piece. I mean, you could simplify this, take its natural log, then multiply by 92, subtract that value from the 57. Or as long as you're good with your parentheses, you can just plug this whole thing in. This is just a chug it out. I think it's a 3, sorry. No, it's 5, sorry. So chug that whole thing out, and you will end up with a value, I believe it was 68.76. Be sure to answer that in a sentence. The price will be $68.76. It doesn't have to be a complicated sentence, but it should be a full, robust, complete sentence. And again, just like the other one, you should expect to be able to, if you were given a price per seat, that you should be able to solve for that n. The process is a little bit different, but it is a process that you guys have been exposed to that you should be aware of the steps that you want to take to find it. Okay, let me get a new sheet here for number 5. 5, you're asked to use your properties to expand. And let's look real quick at those properties. You've got log base b of u times v is log base b of u plus log base b of v. You got log base b of u divided by v, it's a quotient property. Log base b of u minus log base b of v. And the power property, log base b of u to the n is equal to n log base b of u. And these logarithmic properties being logarithms, they should be associated with exponentials, are really just the logarithmic versions of some of your more common exponential properties. The fact that, a to the m plus n is equal to a to the m times a to the n. What happens when you multiply two things? Well, when you multiply two things with the same base, you add their exponents. Well, logs ask, what happens with the exponents? Well, what happens with the exponents when you multiply? Well, you take the exponents and add them. These rules say the exact same thing in exponential form over here, in logarithmic form over here. If you've got a to the m divided by a to the n, well, what did you do with the powers there? You subtracted them. This asks, logarithms ask, what happens to the exponent? What is the exponent when you divide two things? Well, when you divide two things, what happens to the exponents? With the same base, you subtract them. You subtract the exponents. What happens to the exponents when you divide? You subtract. A to the mn, when a power is raised to a power, when an exponent has an exponent on it, you multiply them. Well, what happens to the exponents when you have something raised to a power? Well, you take that power and you multiply it by the other exponent. This says this. It just says it in logarithmic form instead of exponential form. So, when we're told that we have the log base 2 of this large complex statement, 8x to the third over where is it, y squared to the fourth, we can use these properties to break this down. Now, fundamentally, this is the log. The fact that the base is 2 doesn't matter. The base just stays the same in all of these properties. Fundamentally, this is some object raised to a power. So the first thing we really have access to is this power property. So this is something raised to a power, so we can bring that power down as a multiple using the power property. 4 times the log base 2 of 8x to the third divided by y squared. Now we have the log of a quotient, and we're told here that what happens to the exponents when we divide? Well, we subtract them. This log is what happens to exponents when we divide. Well, you subtract them. 4 times the log base 2 of 8x to the third minus log base 2 of y squared. Make sure this 4 is going to multiply by both of them, either by distributing it in or leaving it out for a little while. It really is, at this point, up to you. Now, this is the log of something to a power, so we can use the power property there. But this is the log of two things multiplied together, so we could use our product property to separate those. Log base 2 of 8 plus log base 2 of x to the third minus log base 2 of y squared. Could have applied the power property there, but I was going to do it all at once down here. So 4 times log base 2 of 8 might be nice to recognize that 2 to the third is 8, so that's just a 3. Plus our power property says we can bring down that 3 times log base 2 of x minus, again, the power property says we can bring down that power, so 2 times log base 2 of y, all times 4. Distribute that 4, and you get 12 plus 12 times log base 2 of x minus, 8 log base 2 of y. The nice thing is, particularly for those who are going on to calculus, this becomes a pretty important tool, because having our calculus tools work on a statement like this is pretty nasty. But if we can introduce a log and use the log to break it down into these very comparatively simple individual statements, using your calculus on these individual statements is comparatively easy. So it's a nice way to take complicated expressions and simplify them nicely. Make sure you practice these. There are some wiggles here and there with these types of problems. Make sure you've had enough exposure. Okay, I'll see you on the next video for more of the problems.